All right, so section 4.4 is going to talk about the area of a triangle. And the first thing we're going to talk about is the area formula you've seen before. So what is the area formula for a triangle that you remember from, I don't know, elementary school is probably when you first see it, at least middle school. Length times width times height is the volume of a cube. There we go. We got a 1/2. And then we take the base times the height. And it is related to the area of a square, which is where you were kind of coming from, Aaron. The area of a square is length times width. And then we do basically 1/2 of that when we work with triangles. And we don't call them length and width because of the way that the triangles are shaped. We call them base and height. And this works great if you know the base and height, right? But the triangles that we've been encountering, we don't know that kind of information about them. Typically, we either know the side lengths or the angle measures. Agreed? So it would be much more helpful to us if we had an area formula that's related to the side lengths and or the angle measures that we could use. And in fact, we have two different area formulas that have those features. The first one that we're going to talk about has the angle measurement feature to it, and there's 3 of these, but they're all virtually the same. They have the 1/2 involved, just like you're used to seeing. And they do have 2 of the sides involved, so they either have side A and B, or B and C, or A and C, which I'll write the other ones in a moment. And then they have sine of the angle that we don't have the side information for. And I'll show you briefly. Let me write the other 2 formulas down. So if I have B and C, I have sine of A. And that's probably why they're doing it. This A over here is for area. Let me rewrite that to say that, because I don't want you to confuse that with the angle A. These are all measurements for area. Your book is using K for that. I don't exactly have a good reason for why K, but they are using that. And then sine of angle B. Let me pause for a moment and show you why in the world this sort of comes about by taking a look at a triangle. So if you had a triangle, like so, and you did know one of the sides, namely, let's say you knew the base of this side. So you knew that this base down here was 5. That'd be great because I know I can do the 1/2 times the base, but the problem is that I actually don't know the height, because see the height would be right here, and this, because height is always measured from at a 90-degree angle. Say it that way. And if I'm not dealing with a 90-degree triangle, whoops, that didn't look right at all. If I'm not dealing with a 90-degree triangle, I don't typically know the height of my triangle. That's not information that I use on a regular basis. I'm far more likely to know the other sides. So let's say for a moment that I knew that this side over here was a 4. That can't be. No, that's fine. We can do 4. Then if I actually knew the angle here at the top, then I would be able to actually make the determination and find the height. And I'd be able to find that height based on knowing, or one of these angles here on the sides or whatnot. I would be able to find the other angle in my triangle, because this is a right triangle. Let's actually just say we knew that this one over here on the left. If I knew this angle right here was, say, 30 degrees, let's pose for a moment, if this angle were 30 degrees, could I find this angle at the top? Sure could. And using law of sines and whatnot, I could do the same thing to find the other angles. And I could find the height. Agreed? And I would find the height using trig functions, either sine or cosine or tangent, whatever information I'm given. I would use trig functions to find that. That's what's coming about in these formulas, is that you're actually finding the height, the piece that you don't know based on that information. It's hidden. You don't actually see that that's what's happening, but that is what's happening in there, okay? You're actually shortcutting the system and not having to find the height by using one of these formulas instead. All right, so the good information is that if you're given a particular problem with an angle and 2 sides, and they are all different, right? Angle C, side A, side B, I can flat out use one of these area formulas, and I don't have to do a lot to use them. So the area equals 1/2 what? Right, AB sine C, that's the formula that will match my letters that I'm given. So I have 1/2, side A is 21.9 kilometers. You can just put the 21.9 in there. Side B is 28.4 kilometers. And then I've got sine of angle 142.7. And I don't even need a picture to do this, right? Which, if I were finding the height, I would need a picture, because that's how I think. And I would need to know what pieces I have and where they were going and which height I was looking at and whatnot. I don't need that for this because they fit so nicely into my formula. So if we multiply everything out with 2 decimals of accuracy, what's the numerical value that you get? 188.45. What are my units? Ah, good, somebody said it. Kilometers is correct, and then I actually need them squared. Why? It's area. And realistically, from the formula that I didn't actually write them in there for as well, I actually had that, right? This is kilometers, and this is kilometers. And when you multiply kilometers and kilometers, you get kilometers squared. So it's in the formula, okay? But you can do it at the end as well. That's fine with me, and write kilometers squared because area's got square units. All good? And that's fabulous if you know 3 pieces of information and they're all different. But sometimes you don't. What about this problem makes it different than the last problem? I mean, I've got an A and a B and a C. I know 2 angles, and none of those formulas that I just gave you had 2 angles in them, did they? No, but you do have formulas that allow you to take 3 pieces of information, right, in this case 2 angles and a side, and find the piece of information you need to find. So I either need to find side A or side C. Does that make sense? I can go back, Tiffany. I need to find either side A or side C, correct? Because then I can use the pieces of information I was given, and then the angle and the side B, which I was also given, and I can actually put them in the formula, any one of the 3 formulas anyway that I was working with. So I tend to think that maybe we want to find side A or side C. Which one do you want to find? It doesn't really matter. So somebody pick A. Thank you. We're going to find side A. So my formula says that I'm going to do side A. Do I have my signs on top or on bottom in my formula? On bottom? Okay. So you can write the formula either way. I just want to stick with what your book has. So A over sine of 30.5 equals what? Now what am I going to do? B, well that's 13 over what?
36.9.
Okay, sine, and how did we get 36.9? Because I don't see that anywhere yet. Good, so you guys found angle B, right? You can find angle B if you know angles A and C. So B is angle 180 minus the 30.5 minus the 112.6, all in degrees. And I'm going to take your word for it. You got 36.9 degrees. Several of you said it, yeah? Perfect. All right, so we have A over sine 30.5, 13 over sine 36.9, and we should be able to either cross multiply or simply multiply, right, by this piece to the other side. So I have A equals 13 sine of 30.5 degrees over sine of 36.9 degrees. What is side A? With 2 decimals. Always 2 decimals for our sides unless they say otherwise, okay?
10.99.
That's correct. Good, and it is in centimeters, thank you. All right, so this is my side A. So now I have side A, which I need. I have side B, which I need. And what other piece of information do I need? Angle C. So make sure you're using the right pieces of information because now in this particular problem, you have all of the angles listed. You've got 2 of the 3 sides listed. Make sure you pick the right ones, okay? Don't just pick what's there and just think that's going to work. You have to pick the right ones. All right, so my area formula then, did I give myself more space? No. All right, it's okay. My area formula is going to take 1/2. I'm going to use sides A and B and do the sine of angle C. So I have 1/2. Side A is 10.99. Side B is 13. And then I've got sine of 112.6. And it should be, of course, right beside it, but I don't have space. So pretend. All All right, so what is 1/2 of 10.99 times 13 times sine of 112.6 degrees? What's 9.5? Okay, 9.5.
Oh, what did you want?
No, you're fine.
Oh,
What's next?
what did you-
Centimeter squared. Very good, Erica. Yeah, centimeter squared. We still want the units. I'm sorry, I didn't mean to confuse you, Lauren.
No.
You're fine. The number's fine. Yeah. So 65.95, still 2 decimals unless we're told otherwise, okay? And occasionally you will be, but 65.95. And then it's centimeters squared for area. All good? Okay, there is one other formula for area that we're going to use. And this formula, sort of, if you think about what we just did, the formula that we just used sort of had the feel of sine, the law of sines to it, right? In fact, we use the law of sines to find the piece of information that would allow us to use that formula. I have a couple of sides and I have an angle, right? Law of sines has that kind of information in it. Heron's area formula for a triangle is using the different sides of the triangle. So his formula has to do with if you knew all 3 sides. So my area equals the square root. I'll define what S is in a moment, but it's S times S minus A. It doesn't look good. Let's try again. Times S minus B times S minus C. And it is all underneath a square root. Now you know what A, B, and C are. What are those? Those are the sides of my triangle. So what in the world is this thing S? Well, S is 1/2 of the sum of my 3 sides. Okay, so the first thing you have to find when you're working with Heron's area formula is to find this thing S. Okay, you add the sides together and you divide by 2 or multiply by 1/2. That gives you S. And then I take that value for S and I multiply S times S minus 1 side, S minus the second side, S minus the third side, and multiply them all together. I take that product and I take the square root. Everybody good with that? Okay. Now, could we use the different sides of the triangles and find an interior angle and then go back and use the other formula? Could we do that? Yes, we could do that. We could use my other area formula and it'd be okay and it would work just fine. But I contend that it's probably easier to add my sides together and divide by 2 and then do the square rooting than it is to go finding the angle. It's just a little bit less work. Again, when you get to your tests, I'm probably not planning any way, shape, or form to say, hey, you have to use this particular area formula. I'm just going to say find the area. And if you choose to use Heron's formula versus the law of sines kind of formula, that's okay. You're the one who chose to the amount of work that revolved in, was involved in either one of them. That's fine. So either way will work. We're going to do an example so you can see how we work with this. So we have the 3 side lengths. They all have decimal points and whatnot. And I just told you a minute ago, what's the first thing we're going to do? We're going to find S. So S is going to be 1/2 15.89 plus 21.74 plus 10.92. And when I actually add these and divide by 2, no matter how many decimals I have, I'm going to write them down. Generally speaking, you're not going to have more than, I can't remember if it's 3 or 4, so it's not going to be a whole bunch. But don't shorten this, okay? Keep it exact. We're not going to round in the middle of the problem. What is S?
24.275 inches.
It would be inches. I'm not going to put my units here because I'm not done with my problem. But if you did put inches there, it would be okay. Okay, is everybody all right? Easy enough. Add and divide by 2. Okay. And then when we find my area, that piece requires more work. Because I've got a square root. I've got S, which is 24.275. I've got that same 24.275. I have to do minus A was 15.89. Again, that same 24.275. Minus B, which was 21.74. And then this is still underneath my square root. Pretend like you can see it, but you can't. My screen's not big enough. Or maybe I write too big, I don't know. 24.275 minus the 10.92. Okay, so that's multiplied underneath just like it should be right beside it, like the other ones were. All right, so what I'd like for you guys to do first is not to do the square root part. Do everything but the square root. So take these and subtract them. Make sure you're getting all your parentheses. So if you open a parentheses in your calculator, you need to close one. Okay? But your calculator will let you enter all of that just fine if you have one of the graphing calculators, which is what I see the majority of you having. If you don't, if you have a scientific one, you might have to be a little bit more careful with your parentheses and opening and closing. But what do you get when you multiply each one of these out underneath? Okay, do I have multiple people getting that?
Yeah.
Okay, 6,891. Does it have some decimals or anything?
Yeah.
Okay, so just give me maybe 4 of the decimals for now. Okay, and then you're going to square root that. Okay, so take the square root of that, or if you are seeing that on your screen and you don't want to do square root, you can do a raising it to the power of 1/2. That's the same thing if you remember square roots are powers of 1/2 from algebra. So you could do that from your calculator screen. What do you get? With 2 decimals? Inches squared. Good. Inches squared, or you could write or say square inches and it would be fine too. So you get.
Show that much work whenever we're working, or are we just doing this for the sake of an example problem?
Well, I want you to show me that you can write this out. Okay? So I want to see that piece written.
Okay.
After that, you can jump straight to this point right here and give me the answer if you'd like. That is perfectly fine. Yes. The more work you show, though, Alex, just as a precautionary thing, the more extra credit, not extra credit, but partial credit I can give you in case you have a calculator error or make a mistake. So I always want to receive this piece right here because it lets me know whether or not conceptually you know where things are going.
I was just wondering
And then
if
after
I
that,
wanted
this piece.
Because I didn't do that in other.
Yeah, you don't have to show this piece right here. I need to see this piece, though, the piece where you've
Okay.
shown the pieces plugged in.
So you,
Okay?
okay.
All right?
But so it's the same for the stuff in the log cosine?
Yes, show me one piece where you've plugged it in, and then if you don't need, if you can do it, all the multiplication with the cross multiplication and whatever, not, that's fine, but you need to show me one step where you've plugged the things in the correct place. Yeah. Any other questions about what you would expect to see, or I would expect to see? Okay.